is often taxing to read or write very large or very small numbers. Standard form provides an alternative way of writing these very large or very small numbers so that they may become very simple to handle. Hello everyone, this is our junior certificate mathematics lesson. My name is Raiwani Khare and the lesson for today is standard form. With me it's Elena Boaho who will be helping me in today's discussion. Before we discuss, or rather we go further with our discussion, let us have a look at the lesson objectives. The lesson objectives say expressing a number in standard form from ordinary number or in ordinary number from standard form. That is, you are going to be given a situation where a number is written in standard form and then you are expected to write it as an ordinary number, or a number given as an ordinary number and then expected to write it in standard form. Let me invite Boaho here to chip in and say what she wants to say in today's discussion.
Good day viewers. Mr. Khare, you discussed standard form and I'm very much interested in knowing more. I will request you to discuss the principles of standard form. What draws you into conclusion that a number is in standard form?
Thank you, Boaho. You are saying what guides you into saying this number is in standard form? What leads you into saying this number is written in standard form? Let us have a look at what should guide you. But before that, we need to look at what standard form is all about. It says standard form involves writing large numbers or very small numbers in terms of powers of 10. That is, for you to say the number in standard form, you need to make sure that the number is written in terms of the power of 10. So, if a number is written in the form m times 10 to the power n, this number is in standard form. But for you to conclude that it is in standard form, there should be only one digit before the point. So m should be within the range 1, it's less or equals to m, which is less than 10. That is, the value of m should take the range from 1 up to 10. But 10 is not inclusive here, so it's 9 point whatever there. So this is what guides you into saying a number is written in standard form. The two conditions, m times n to the power n, where n is a positive or a negative integer, and then the value of n should be within the range 1 to 10. These two conditions need to be satisfied before you can say a number is in standard form. So every time when you want to check if at all a number is in standard form, make sure that you satisfy these two conditions. And then let us also note that standard form can be referred to as the index form or the scientific notation. So instead of calling this standard form, you may decide to call it index form or the scientific notation. That's the other name for the standard form. Now, let us have a look at an activity which will help you understand what standard form is all about. It says, of the numbers below, tick those which are in standard form. So it means you are going to be given numbers here. The first one is 3.2 times 10 to the power 2. And then you need to tick those which are in standard form. But remember, what leads you into saying this number, or rather what leads you into concluding that a number in standard form, it has to satisfy the condition m times 10 to the power n. And n is a positive or a negative integer. And then the value of m should be within the range 1 is less or equals to m, which is less than 10. Here 1 is inclusive, but 10 strictly not included there. This is simply saying there should be only one digit before the decimal point. Then that's when you can conclude that this number is in standard form. Let us have a look at this. 3.2 times 10 to the power 2. Is it in standard form? The questions say, or the activities say, we are to tick those which are in standard form. So we need to check this, and then if 3.2 times 10 to the power 2 satisfy these two conditions, then that's when you can conclude that the number here is in standard form. So 3.2, this is m, 3.2 is m. But then check, does 3.2 fall within the range 1 to 10? It's 3.2, so it does. The first condition, rather the second condition has been satisfied. What about 10 to the power 2? The value of 2, rather the value of n has to be a negative or a positive integer. So we've got a 2. 2 is a positive integer. So the two conditions has been satisfied. So this is in standard form. We tick it. It's in standard form because the activity says tick those which are in standard form. Let's check the second one. 19 times 10 to the power 4. 4, we need to check if at all our conditions are satisfied. M times 10 to the power n, and then 1 is less or equals to m, which is less or equals to 10. It's 19 times 10 to the power 4. 4 is a positive integer, so this one is satisfied here. But then, the value of m should be in the range 1 to 10. There should be only one digit before the decimal point. But then this is 19. Therefore, the second condition is not satisfied. So this one is not in standard form. So we cannot tick it. Let's go to the third one. The third one is 0.03 times 10 to the power negative 3. Negative 3, this is a negative integer. So it does satisfy situation where we are saying m times 10 to the power n. So it's negative 3, which is an integer there. But then what about the value of m? We are saying m should be within the range 1 to 10. So this doesn't satisfy the second condition. So this is not in standard form. And then let's check this. 1.0 times 10 to the power 5. 1.0 times 10 to the power 5. The first condition, m times 10 to the power n, and then the value of m should be within the range 1 is less or equals to m, which is less than 10. So the first condition, where n is an integer, 5 is an integer, satisfied. And then what about this one, 1.0 times 10 to the power 5? The value of m should be within 1 to 10. So this is also satisfied. This is in standard form. It's in standard form. And then, what about let us take this one. This one I may give it for you. Go and have a look at it. Let us have a look at 5 times 100. 5 times 100. This one, check if at all the conditions for standard form are satisfied. M times 10 to the power n, and then 1 is less or equals to m, which is less than 10. So 5 times 100. 100, this has to be written as a power of 10. So straightforward, the first condition there is not satisfied. So this is not in standard form, as we can see. And then let us have a look at this one, 4.2333 times 10. The conditions are m times 10 to the power n, and then 1 is less or equals to m, which is less than 10. If we look at this, this is just 10 to the power 1. So the condition for the integer there is satisfied, this one. And then the value of n should be within the range 1 and 10. But then what we are having here is 4.2333. It's within this range. So this is in standard form. I know it may confuse you to say 10 here is not raised to a power. It is raised to a power 1. And then when a number is raised to the power 1, we don't write that 1. So this is just 10 to the power 1. It's in standard form. So 4.2333 times 10 is in standard form. And then let us have a look at the last one. Let us have a look at the last one. Or let me write it for you because it's very important that you note it. If we get 2.33 times 10 to the power 1.25, the conditions are, for you to say a number is in standard form, it has to be m times 10 to the power n, and then the value of n should be within the range 1 to 10. So the range here for m is okay, it's 2.33. But when we check 10 to the power 1.25, This is not an integer. And because it's not an integer, it means this number is not in standard form. For a number to be in standard form, the value of n should be an integer. That is, it's supposed to be a negative or a positive whole number. That's how we write numbers in standard form. All you need to know is to make sure that you apply the two conditions, m times n to the power n, where the value of n should be within 1 to 10. That's how we write numbers in standard form. Let us go for a short break. When we come, we'll continue with our lesson. Welcome back from the short break. Remember, we are still discussing standard form. And I want to give this chance to Boaho to ask another question so that we can go on with our discussion.
Thank you, sir. I got the concept. Sometimes numbers can be written in ordinary numbers and expected to be changed to standard form. Others in standard form to ordinary numbers. How do you do it?
Thank you, Boaho. Your question is then, how do we write numbers in standard form when they are written in ordinary numbers? Let us have a look at examples and try to convert from ordinary number to standard form. We've got examples here. 750,000. So this is an ordinary number. So how do we convert this ordinary number into standard form? Remember, for you to say a number is in standard form, it has to be in the form m times 10 to the power n. Then if the number is written in this form, where the value of m is within the range 1, it's less or equals to m, which is less than 10, then a number is in standard form. So what you are simply saying here is there should be only one digit before the decimal point. So what you are having here is 750,000, and it says write this in standard form. So 750,000 in standard form will be the point. We'll take the point to be at the last 0 here. And then this will be, remember, we are saying there should be only one digit before the decimal point. So we'll try to achieve that by saying if the point is here, then we'll move this 1, 2, 3, 4, 5. We have moved our point 5 times to the left. So this will be 7.5 times 10 to the power 5. 7.5 times 10 to the power 5. The point was here. And then we moved 5 places to the left. 1, 2. It's 1, 2, 3, 4, 5. So 5 places to the left. And then that means it's times 10 to the power 5. The zeros here, unless if the question is testing accuracy, that's when you can write the zeros here. But otherwise, 7.5 times 10 to the power 5 will give you the ordinary number 750,000. So the zeros after 5 here are not that important. So the answer is 7.5 times 10 to the power 5. And then let us have a look at another example. 3.5 million. So 3.5 is in ordinary number. So we need to write 3.5 million in standard form. That is from ordinary number to standard form. 3.5 million will be 3500, then 1, 2, 3. This is 3.5 million, and we are to write this in standard form. When we write this in standard form, this will be equals to, the point is just after the last 0. So you move your point to the left so that you have a situation where there's only one digit before the point. So this will be 1, 2, 3, 4, 5, 6. So you moved 6 steps to the left. Then this will be 3.5 times 10. How many steps did we move? 6. So it's 3.5 times 10 to the power 6. That's how you write 3.5 million in standard form. We are now to look at the second example, where we are changing from ordinary number to standard form. 0.00832. Change this to standard form. Remember, there should be only one digit before the point. Now, the point is here. How many times will we move this point so that we achieve a situation where there's one digit before the point? This will be 0.000, not 8, but 0.000832. Now, the point is here. We need to move this point such that we achieve a situation where there's one digit before the point. So, 1, 2, 3, 4. This then will be 8.32 times 10. But then, remember, we were moving the point to the right. Because we are moving the point to the right, it means we are now multiplying by 10 to the power negative 4. Because we moved 4 steps to the right. 1, 2, 3, 4. So, this will be 8.32 times 10 to the power negative 4. Let us have a look at another example. We've got 35.6. And then we need to change this to standard form. This will be 3.56 times 10. The point is here. We move it to the left so that we achieve a situation where there's only one digit before the point. Then this will be 3.56 times 10. It's in standard form. This 10 here is 10 to the power 1, but because it's 10 to the power 1, we never write that 1. We just write it as 3.56 times 10. It's in standard form. And then let us have a look at the last example under this part, 67 times 10 to the power 3. So we need to change this into standard form. It may appear to be in standard form, but in actual fact it's not, because when we check the 67, it's 67, and we are saying there should only be one digit before the point. So this is not in standard form. So if I had to write this in standard form, it will be 6.7 times 10. When we change 67 into standard form, it becomes 6.7 times 10. And then we need to multiply by a further 10 to the power 3. So times 10 to the power 3. This simplifies to 6.7 times 10 to the power. The laws of indices says when the bases are the same, you add the powers. So we've got 10 here, 10 to the power 3. So this is 10 to the power 1, 10 to the power 3. So we add the powers. 1 plus 3 is 4. So the answer is 6.7 times 10 to the power 4. That's how you change 67 times 10 to the power 3 into standard form. The answer is 6.7 times 10 to the power 4. Let us go for a short break. When we come back, we'll continue with our discussion. Welcome back from the short break. Remember, we are still discussing standard form, and I'm still with the learner here, Boaho, who is helping me in today's discussion. And I want to give you another chance to ask a question with regard to this topic.
Thank you, sir. I appreciate your presentation, sir. Another thing, sir, what about changing from standard form to ordinary numbers? I guess it's possible.
Thank you, Boaho. You are saying then, how do we change numbers from standard form into ordinary numbers? Let us have a look at examples here because they will help us understand this question you have just asked. 1.35 times 10 to the power 3. This is in standard form. You need to change this now into ordinary number. So how do we change this into ordinary number? This is just the multiplication that you know. So when you change this into ordinary number, it will be 1.3 times 10 to the power 3. And then the 3 here simply says you are to move the decimal point to the right. Move the decimal point to the right. So it's 1.35 times 10 to the power 3. This will be, the point is here, so we need to move it to the right. So I'll write this as 1.35. And then upon moving this to the right, the point to the right, it will be 1, 2, 3 here. Now, this gives us 1350 because this simply says we have to have a 0 here. So upon changing 1.35 times 10 to the power 3 into ordinary number, we get 1350. This is how we change a number from standard form into ordinary number. Let us have a look at another example. 8 times 10 to the power 4. So write 8 times 10 to the power 4 as an ordinary number. It's from standard form to ordinary number. So this will be 8, and then we take the point to be here, just after the 8, because it's in standard form. And then it says move the point 4 times. And then upon moving the point 4 times, it will be 1, 2, 3, 4. So we'll have zeros there now. 1, 2, 3, 4 here. So this simply says when you change 8 times 10 to the power 4 into an ordinary number, you get 80,000. This is 80,000. This is how you change a number from standard form into an ordinary number. And then let us have a situation where the power of 10 is a negative number now, and we are to change 5.61 times 10 to the power negative 6 into an ordinary number. So this will be 5.61. The point is here, and then the power is negative. It's negative 6. Now, because the power is negative, this is simply saying move your point to the left. So instead of moving it to the right, you are going to move it to the left because the power is now negative. So you will move this to the left. The point is here, so it's 1, 2, 3, 4, 5, 6. You have to move 6 steps to the left. 1, 2, 3, 4, 5, 6. And then now, this simply means you are going to have 0 here, 0 here, another 0. Should not have this 0 here. We have this 1, 2, 3, 4, 5, 6. So it's a 0 here, and then another 0 here, another 0 here, another 0 here, and another 0 here. So the point is here. And then there should be the last 0 here. So this will be 0 point. And then how many zeros after the point? 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5. And then we'll have the number 5, 6, 1. You can always check if at all that's what we are going to get. Remember, if we are to convert this to standard form, we are going to move this point 6 steps to the right. 1, 2, 3, 4, 5, 6, which is 5.61 times 10 to the power negative 6. So upon writing 5.61 times 10 to the power negative 6 as an ordinary number from standard form, you will get 0.00000561. This is how you write a number in standard form a number in ordinary number from standard form. All you need to know is to check if the power is negative, you move your point to the left. If the power is positive, you move the point to the right. So let us have a look at another example. 2.7 times 10 to the power negative 2. 2.7 times 10 to the power negative 2. We are to change this into 2.7 times 10 to the power negative 2 into an ordinary number. It's in standard form, so you have to change this into an ordinary number. The power is a negative, and we said when the power is negative, you move your point to the left. And then here, we are going to move the point to the left. How many times? 2 times. So it's 2.7. And then move your point to the left. 1, 2. So the point will be here. Then this will be 0. This is simply saying 2.7 times 10 to the power negative 2 is equals to 0.027. This is how you write a number as an ordinary number from standard form. All you need to do is to check where your point is. If the power is negative, move the point to the left. If the power is positive, you move to the right. we have now come to the end of our lesson, but before we end this lesson, remember we were changing ordinary number into standard form, or numbers in standard form into ordinary numbers. Now, when you change numbers into ordinary numbers, you make sure that you move your point either to the right or to the left. Then that means you have changed from standard form to ordinary number. Or you can also be expected to change an ordinary number into standard form. When you change into standard form, note that you are to multiply by a power of 10, and there should only be one digit before the decimal point. That's all I had for you today. Until we meet again in our next lesson, bye-bye.